I'm going to be here standing and making an argument for an Atlas 15. So if you want to know what we really are going to want coming out of this is Atlas 15. That's our primary guidance, design guidance from that. So again, I'm Shirley, incoming president of EWRI, and I'll start from there and give you a little bit of historical background. Let me find the right buttons. There they are. Come on, work. There we go. Just as a quick heads up, and I'll put a few pictures in to illustrate this. We come at it from a different perspective. And again, just listening to the SCI presentation on future scenarios, we've really come off of a lot of drainage design, and that's been a lot of it's been local. So even when I get to our standards near the end of this, it seems like what we're really telling people to do is go get that local data and work with that. So that's why for us, getting that localized information into NOAA Atlas 15 is critical. Again, it comes off of the challenge, initially came off the challenge of water encroaching on pavement. And again, the safety issues that are associated with that. How big then do our inlets have to be? How big do our curbs have to be? Things like that, that we're really trying to address coming in with that. And I just want to put this one up there just to give you an idea. I mean, this comes and predates a lot of these standardized guidance that came out or ties in concurrently with that. But I will highlight some things, which you're just going to start seeing in here is how different some of these requirements are, which is why, again, that NOAA Atlas 15 is critical because different places have different requirements and everybody wants to reach for now Atlas 14 or their local information to grab that. You can see everything from a 2-year and 10-year 2-hour storm to 24-hour storms up to 100 years coming across the board. And again, particularly when you think about peak discharge, we're talking about the, obviously the peak flow rate of water heading for our gutters, our curbs, our inlet structures, and of course, then all of our stormwater management practices. We do also address volume issues. So we're going to be talking then again, coming off of NOAA Atlas 15 with the idea of what those bigger volumes are up to potentially 100-year volume. So just to give some ideas, this is some of the historical, and we do see this more codified in different locations. We are starting to standardize around some numbers, typically the 10 to 50-year storm, but at various time frames. Again, because we're just trying to design a lot of different devices that are going to be above ground, below ground, everything from treatment systems to inlets coming across. And each of these have different criteria for their sizing. Again, with obviously structures that are designed to hold more water, even in your residential detention ponds, are going to be looking at having what we, again, back to that discussion of risk, having a probability of exceedance that's going to be smaller within a return period that's higher. Again, we talk about stormwater treatment. You can begin to see, again, as you come across, we've used flow and we've used volume on this right side as a surrogate for pollutant removals. So you can see on here everything from the 6 month to 24-hour storm. So you can see how we're even going down to smaller than a 1-year storm size to do that, in addition to just calculating then the runoff volume itself. So again, I want to throw some in there. A lot of this again comes in from this idea around highway inlet design. You can see our lovely inlet on grade. We've assigned an efficiency to it. We assign a size of flow to it, with the idea that if it's not captured up here on the grade on the side of your roadways, somewhere at the bottom of this, we'll have a sag inlet that's going to be designed for a higher storm size. Because again, it's got to try to drain the entire set of water that would collect in a low point, such as in an underpass. And this is, by the way, not far from my house. So I just try to put through some pictures in to illustrate what the challenges are going forward. And this is a lot of what's out there. Some states have different criteria, but let me give you an idea of where we're coming in with design. You can see the range of design storm sizes or the inverse of exceedance probabilities based on the size of the road, the speed of the traffic that it's handling, and how much of the road can actually be covered with that. So again, if you haven't really thought about it, the good news is your interstates, they would prefer to only have the shoulder covered. But if you're driving down your local street down near your house, they may actually take a half a driving lane on both sides where we're allowed to put water and have it stand until it drains down, so that effectively for emergency vehicles, the crown of the road is clear. So again, we start getting into the larger ones. We're starting to talk about larger storm sizes for our critical roadways, our emergency streets and things like that. I did want to pull this out of the report that NOAA and ASCE did. It was released a couple of months ago to just try to give an idea. These are all of the standards we feel that are going to be impacted by bringing in NOAA current data and then how they fit into the various sensitivity groupings. I did add in the one that was missing, that I thought was missing on there, was the erosion control standard. And it is an important one. It's going to use the same data, so it doesn't change the data type and it doesn't change the issue. But many of our construction sites, particularly for large projects, particularly now with all the infrastructure money coming out, those are multi-year projects with multiple amounts of land that is basically unvegetated and exposed or temporarily stabilized, where that climate data, the intensity of storms, the volume of water that's coming in, and even to a point on the flip side of it, the drought side, when the vegetation doesn't establish, are going to be impacted. But again, the ones that we've really been talking about in here are particularly 45, 46, and 47, as well as then 62, 63, and 64 are the ones that we've typically focused on in that. We also have, as Dan advertised in the presentation, I didn't put it in here, but MOP 77, which is the design of urban stormwater management systems. They all are going to use the same type of data. So that's the good part. Like I said, we're advocating for NOAA Atlas 15. Just to give you an idea, I'm going to pull back out our current version, and this will go back to these were actually released in 2016. They're a little bit slow coming through the review process, coming through the pandemic. They are going back under review, but just to give you an idea of how things are in there, I put in bold what the kind of criteria are that are recommended in there. Again, you notice in here, it says basically you're going to have to go back to your local ordinance because it is local design. And again, for that, but we were talking about 2 to 15 years, typically a 10-year design is common. Some places to account for climate change are going to 25 years until we can get NOAA Atlas 15. And then, of course, in the high value districts, maybe the storm sewers 10 to 100 years. There's very little 100-year design that I've seen out there. But going with that, again, is in here is this idea, just quickly to come back in from a design standpoint. We're very nice. We reference all of our old designs, but typically what has come in our criteria said I did highlight the important part in bold. The National Weather Service talking about IDF curves for many of the first order stations, and the information is site specific. So we're very much giving our clientele, the people who are reading our standards, the people who are adopting our standards, this idea that still very much is a local control issue. So we don't really have, we're very different than ASCE 7 because it's just not as widely adopted, but it is the same type of information that is being pulled in that respect, that people are reaching. Our standards agree with a lot of the ordinances, and ordinances agree with a lot of the standards, and our standards are referenced, but it's not quite as prescriptive as asking, for example, for a 500-year, 15-minute data point. We're really looking at that spectrum. And I want to come across with that because it's coming in with a concept that, again, for those who didn't take hydrology, it's called time of concentration. And what we're really trying to say with this is how long does it take water to get from up here on the ridge top all the way down to the outlet that we've designed, whether it's a storm drain inlet, whether that's a detention pond, a culvert, whatever it is. So I think about an urban neighborhood and a storm drain inlet may drain a couple of houses. That time could be as small as 5 to 10 minutes. And I would need my climate data based on a 5 to 10 minute length. So again, whereas a culvert under a highway could have several hours of time. So I'm going to think about going to NOAA Atlas 14 right now. I would go in and I would grab, the data right now. I might say if I have to do a 10-year design, I'd be looking at a 10-year return period, and then I'd be coming back in and looking for a time frame that would get me, say, a half an hour or 5 minutes or 2 hours or 24, depending on the method and the time frame I've got with this travel time concentration. So again, we're designing everything from these little inlets on the side of a road you can see to these bigger culverts, and all of these are being designed off of information that currently is coming out of NOAA Atlas 14. So that's where we're coming in from that. So I'm going to throw ahead. Again, the other end, we don't do as much of it, but we do have a hydraulics and waterways group that does work around dam performance. And obviously in here, we're dealing with that in terms of potential for damage, and then what are the time step classes and the annual exceedance probability, typically, 1 in 500 exceedance probability, again, ranging up depending on what the hazard is, what exactly the design performance standard should be, all the way out to the PMP, probable maximum precipitation. So you can see we actually go across that entire range of rainfall. While we're asking for the world, we're going to put the world out here on this request. Again, seeing what we can get at what time frame. On the good side from our standards, as I showed earlier, we do typically say reference what's current. We're not quite as prescriptive in having to have very specific numbers. I did put this in here, and I'm going to see if I can do a quick change over. I just want to highlight this one. Hopefully people can see the new screen on Google is that I just pulled up, the NOAA data, just trying to get the NOAA data as you guys are going forward, thinking about ease of access. The purple dots are hourly data. The blue dots are 15-minute data. And people are really also trying now to build data sets based on real rainfall data, going back in with that. So that's becoming critically important as part of that, being able to get back in and get data, and even sometimes at a smaller interval than that type of data. Let me come back over and see if I can move forward. And I put that in here, and of course I forgot, I screwed up, and apparently I didn't set this so the other one go in the background. My apologies. I'm not going to try to change it now. But the graph is something we worked with across Pennsylvania, and I want to highlight that one as one of the other challenges we have. The black bars are the Federal Energy Independent Security Act that was passed about 8 to 10 years ago. And their 95th percentile rainfall says take daily rainfall, throw out everything less than 1/10 of an inch, and then organize everything smallest to largest, take the 95th percentile. And that's the design rainfall we have to use. We did the exact same thing with it, but we took our local stations, and these are stations across Pennsylvania, except that we didn't divide it by, we didn't do a midnight to midnight analysis. We actually took the rainfall, broke it into 6-hour interval, a 6-hour dry period considered to be a break between storms. Because what we do know is that storms happen across midnight. That did last night at my house. So if you divide it by, if it's a midnight to midnight arbitrary definition of storms, we potentially miss the challenges of multi-day storms or storms that go over midnight in these analyses. And what you can see with that is that this is the exact same thing about throwing out everything less than 1/10 of an inch, taking the 95th percentile, same rainfall record. But what you see is almost every one of these red bars is higher than that. And that is that 95th percentile depth for storm events, as opposed to being based on that calculation, being based on the daily rainfall data coming out from NOAA. So that does say that we are also already potentially under designing, because we're not looking at storm events as opposed to taking this federal arbitrary defined storm event of a midnight to midnight based on how currently NOAA's data is reported out there on these daily weather stations. So it is one of the challenges. And of course, getting smaller increment data is also a challenge because that's not available everywhere. I'm very fortunate. It's about a mile from my office. So I'll throw that out there as a possibility. And Megan, I owe you slides because that last one's not in here. So just to summarize again, we're obviously basing it on a risk-based calculation. We really don't have a prescriptive national standard, and talking to our committees, they don't really want to sit down and say, you have to use the 10-year storm or you have to use the 25-year. But typically that is kind of in that range of what we've been designing for the 10 to 25-year event for your normal stormwater drainage that would be in your municipalities. Interstates often kick to a 50, preferably to a 100-year event. Those times are very important, again, because we're really trying to look at response times and we're looking at peak intensities. And if you think about it, the higher the peak intensity, inches per hour, the higher the higher our flow rates are, so the bigger the pipe has to be. So again, that time increment design drives that selection of the time increment used for the design storm. And again, in small urban catchments, it can be as small as 3 to 5 minutes, obviously to several hours to a day. We do, just as a heads up, we've been doing some listening sessions. We've had a variety of jurisdictions and committees asking how to incorporate climate change in design. We already know some of them have developed their own designs, have developed their own IDF curves. Others are already using multipliers. And one way they're coping now to jump to making a larger design storms. We are seeing, just going back to what I just showed on that last slide, some jurisdictions are proposing that they're going to develop a one or more real storm events, just taking a real storm set, using the 6-hour inter-event criteria, and running it through the designs as a validation or confirmation of that design. Again, I didn't put on this slide, but dams are going to be sitting on a higher design criteria, looking for higher levels of data. But they are going to be running these flood hydrographs through the dams to see how the emergency spillways and how the reservoir capacity is holding. So that's our fundamental request. And so again, our urban drainage standards are in the review process. We are not quite as tied to the time frame that SEI is, but I did want to throw that out there. And with that, I will stop sharing my screen.
All right, excellent. Questions for Shirley, because I know I do. All right, I'll try to get the ball rolling here, Shirley. Again, just kind of apples to apples for those of us that don't live in standard world, right? Okay, so with SEI, we know they have a timeline. I know that one of the big issues with what's driving the timeline is they have to have time for balloting and to work it through the committees and then do balloting and maybe reballot, and it's a process, right?
Absolutely.
Now, when you're talking about 45, 46, and 47, for example, are you in a cycle now where you're near balloting? And so I'm kind of trying to understand like when the cycles are going to flip, because everything that I've heard about Atlas 15 is something more along the lines of like 26, 27. So can you just kind of walk me through like where are you in your current cycle? When would the next cycle begin? Where are we trying to get on the train?
Okay, so going back to your question, I would have to actually double check on a couple of things, but here's where I'm pretty sure we are. I'm 90% sure, so let me put a risk probability on that one. Okay, the 45, 46, and 47 and 62, 63, 64 all came out in 2016. Had we not had a pandemic, they would have gone through, and they were starting a review process to be reissued in 2021. So the way we look at it is they will go back in and they will look at the standard just like all the other standards, and they will evaluate whether or not it needs to be updated. Is the material current or does it need to be updated? That should have been an evaluation for 2021. They are finishing working on it now. They're not quite in the balloting, but they are looking at that. We are talking to them because it hasn't gotten to balloting yet about how they would want to add language to address climate. And that is still in the debate process. From a request for 15, I think what we're really looking at is the next cycle. Let's just assume it goes into balloting and we can get it out in late 24. And that may be optimistic, but we'll be talking again, a little behind the line of 728. Maybe this would be, 64, 29 or something, 45, 29. So at that point, for us though, text-wise, it's not going to be difficult to do it. Unless we were to get pushback on using 15, I don't think we are because people are asking for it. Is that we're going to just have to be able to go through and basically do a search and replace 14 to 15. Because again, we don't call out specific values. We don't go in and say we need the 500-year 15-minute one. We're saying, and I could show it back up again, but I think it's probably not worth the effort. We're going in and saying, go look at your local ordinance. Chances are your local ordinance references NOAA Atlas 14 and delete/replace 15 and pull the appropriate data based on your time of concentration and on what the specificity is or what the methodology you're using requires for that input data. So I think, does that answer, Dan, your question in a long way?
It does, but it does beg another question, which is when we talk about Atlas 15, there's Atlas 15 Volume 1, which is done in a manner that's fairly consistent with Atlas 14. It's just synoptic for CONUS and then OCONUS, right? And then there's Atlas 15 Volume 2, which is, the piece that when we were talking with Abby about, how would Ken Kunkel's work on 15-minute rainfall for future conditions match up with Atlas 15? We're talking about Atlas 15 Volume 2. So, what I'm hearing is the plan going forward would be to be, at least for the current version, and I know we're not really, this is up to the committee itself, but what I'm hearing is that kind of the initial fix is just make sure that people know about and are encouraged to use Atlas 15 Volume 1.
Correct.
But if you're designing infrastructure that's going to operate out over the next 30 to 50 years, that at Volume 1 would not take into account future climate conditions. So you don't really have a specific plan for the most current cycle to deal with, long-term future. So that would be in the next cycle, if it happens.
And again, let me come back in. Let me step back, and I probably should have thrown something in about MOP 77 a little bit. So what we are talking about, because that's actually a really good question. I was ducking the question a little bit, Dan. But let me come back in and put it out there. We have put it to the standards committee. We've also put it to our manuals of practice committee. We do tend to operate a little bit more on manuals of practice than SEI does. They're kind of a balancing act in there. There are debates because so much of this is under local control about how we're going to deal with climate. So in MOP 77, and I can say this because I wrote the section, we are giving them references to where they can find current examples of climate data or how people are responding based on what we've heard. There are going to be jurisdictions that are going to want to grab volume 2 and use it. There is no doubt about it. Some of our more progressive cities, those that have been seeing flooding, are probably going to grab volume 2 and say, basically take the volume 1 and use the multipliers in volume 2. Marissa on the Mid-Atlantic has already done that. Some places are starting to adopt Marissa with the multipliers on top of what they know now. So we are seeing that discussion. The Pennsylvania State Manual is likely going to go that route. There are going to be others who are going to simply want to deal with Atlas 15 Volume 1 and leave the flexibility to do it, but not mandate it. So I think that's what we're going to come into, is the fact of the lack of mandates to grab the climate data. So when I'm thinking about a timeline, I'm thinking Volume 1 is really our pressing need, and Volume 2 to hopefully hit the next cycle. And then at that point, internally to EWRI, because this is a discussion we started to have, and it got a little bit on the heated side. So we're still working our way through it. How far do we prescribe more like 728 versus how much do we stay where we are in terms of how we've written this, and basically say, here's where you can find the data, localities do what you want. And we're kind of in that balancing act of having this, and really probably coming down this idea, which we don't have developed, of flow charting and giving people, basically, here's how you should be thinking through it, and you can take your pathways how you want. Because again, we are bumping up against transportation agencies or transportation driven design. That is, and you saw that a lot of this is designed based on transportation, which we can have another discussion on how inadequate that is because of the fact that we're flooding basements. Because people don't realize it's really road coverage where this criteria came from that's being applied in the wrong places. Not that the design's bad, the ideas are bad, it's being applied in the wrong places. That's where the challenge is. And we are having that discussion in EWRI, and we don't have an answer landing on it yet. Of what are we going to do about how much we get closer to prescriptive language versus how much we give. And what's probably more going to happen is, here's the flow chart, here's how you could incorporate it, here's why we would suggest you incorporate it. But it's not going to be as definitive a standard as you're going to see in 728 with the language.
Okay, so what I'm hearing is, and then I'm going to go to Joe, is we have a little bit of breathing room, right, because you're far enough into your current cycle that you're, right, probably not really going to get into at a committee level how to handle future conditions. If the jurisdictions decide to use volume 2 instead of volume 1, that's on them.
Right.
Okay. All right. That's
and MOP 77 right now is structured that way. That says, here's where people are putting climate change in. Here's your reference, okay, but not excellent, saying you have to do it.
Okay. Joe.
Yeah, I wanted to make a couple of sort of overarching comments and maybe questions here. When people talk about Atlas 15, I don't think it's really been set as to how the future is going to be characterized in that I know of.
In volume 2.
In volume 2. And so if the whole push here is to at least have some set of characterization that's along the lines of global warming levels, they may choose to do something else as well, but to have things characterized as this is the uncertainty, local uncertainty given a global warming level of 3 degrees, given global warming 4 degrees, that's really, really important information. It would just be sort of reconfiguring the information, but to have that available in those terms and really getting that feedback into that process sooner than later would be really, really helpful. The other one,
comment right there, Joe, before you ask the question, because we do have, and I live in Pennsylvania. I've been working with the Pennsylvania manual, the new draft one coming out, and they are going in with recommendations around RCP levels. And we were actually having that discussion because, again, it's out for public. The public comment period is over, and there is pushback on it. So whether that's going to land in climate scenarios inside our new manual is a good question, and other states are thinking the same thing. So now to your questions.
Yeah, and my point was that this is a radical departure from the way people have done it. They just want to go to SRCP and pick one that you think, or pick a higher one as more risk. And here you would probably pick a higher global warming level as a higher risk scenario. But I think it just clarifies communication. The second thing I wanted to make, point I wanted to make was, I know we talk about return intervals and 10-year and 100-year floods. And, you know, when I've been starting to write about this, I find it very awkward to go to the more correct, you know, changing exceedance probabilities or annual exceedance probabilities changing through time. But I'm just wondering whether we need to come to sort of some language that we use. Do we just say return intervals, but we know those are changing and we know there's really mean probabilities? Or, you know, I know Abby will have to struggle with this mightily, is, you know, what's the language that's simplest and most easy to communicate and yet gets the ideas that these things are changing?
And Joe, I'm going to add to that, because one of the things we do, and I try to teach, is the fact that these return periods or these exceedance probabilities are typically based on a year. And if you have a 30-year mortgage, which is what First Street Foundation's been focusing on, you have a 30-year mortgage, that probability is not that exceedance probability for 1 year.
Well, that's right. So the other question I have, again, about framing these time-dependent scenarios, is that for an engineer, you know, I've been talking, when I talk to engineers, I mean, different approaches, like, is it failure over lifetime, right? In which case, you kind of want to know the trajectory of this exceedance probability, so you can integrate it. There's all sorts of nonlinear effects that come into this,
Right.
and, you know, and thresholds. So this is more getting back to how the information gets processed and communicated, because we'll have that information.
Right.
It's just a question of whether that makes it into an atlas where you can look it up in such a way that you can, are you just worried about, like, I want to plan for the 100-year flood in 2100, or is it really, as you were putting it, uniform probability of failure across all hazards over a lifetime of project, in which case we have to give you more information so that you can make the calculations. And this is the stuff that I think needs to be, sooner that gets cleared up, or at least, you know, how do you want to put it? A provisional approach gets out there, the better. On my side, you know, so how do I present information?
Yeah, and I would fully agree with that. And maybe that's something we start talking about now, Atlas 15, we start talking about even presenting it as annual exceedance probabilities instead of using the return period, although return periods are very common, or are both terminologies. So people start transitioning that thought process over to that risk-based probability number rather than just focusing on the return period, because we all can talk about how the public misunderstands that number. And so those are, you know, some of the challenges that we've got because we don't communicate risk well. My
solution has been trying to put a double axis on my one, you know, one is return period, one is AEP, you know, annual exceedance probability. Yeah, I use AEP, and then a smaller font I put in parentheses the return period. Yeah, one of return period, yeah. Text, it's along the same lines. No, I fully agree with that. And we do too. Again, it's I'll just give you an idea, Joe, but you raised a quick question. And I did the calculation just because I was giving public comment on the state manual. Well, it's very interesting. I think I want to have our people talk about is that the team that wrote the manual, because that was the way the state contracted it out, put in that they wanted the shorter horizon, was it to 2070 timeframe at RCP 8.5. But if you actually look at the data that's out there, you can do RCP to 2100 of 4.5 RCP, and you actually get the same rainfall amount based on some early projections from Marissa. And actually, I suggested they flip the language over to the RCP 4.5 and use the 2100. You get the same calculation, almost the same rainfall depth. It was like off by a half an inch on about a 3-inch rainfall, or sorry, 4 or 5 inch rainfall. It was less than a half an inch, and it was comparatively, you know, 10-15%, which is given the error bands is already is good enough. Just because it may be more palatable to tell people we're going to design to 2100 given the lifespan of our infrastructure and RCP 4.5, because again, a lot of people will push back and say that 8.5 is an extreme and we're probably not going to do it, although there's a credible argument that we could be getting closer than we want to. But it is an interesting thought about also that just entire communication with the public and communication with regulators, Congress people, all of that, legislators, all of those things as an overall group and as a society, and this partnership should be thinking about.
All right, good point. Carrie, you've got your hand up.
As I apologize, I had to step away. So if I'm repeating something that's already been said, please cut me off. But I just heard all the discussion about mean recurrence intervals, and was just sitting here thinking that that works in a stationary environment, but we likely will have to come up with some other way to describe hazards as we move in forward into a non-stationary environment. And this is one of the big ASCE 7 challenges. I'm on the load combinations subcommittee, and we look at it from a reliability perspective. So that's another entire conversation. How do we measure the environmental hazard with regard to the performance we're looking for? And the mean recurrence interval, even looking back in the past, is only part of it. And I think Brennan referred to it. We have to look at the structural performance alongside the environmental hazard and how they both perform together. So how we're going to do that moving forward is another big question.
Yeah, I hope this kind of collaboration, because I don't normally have a chance to work and talk to SEI and others on a daily basis. Actually, hopefully that can bring some of that discussion forward, Terry. I absolutely agree. Because if we all figure it, we all put our brains together, maybe we can get something together to think this through.
Yeah, it would be good, I think, to have a common basis across the different applications and institutes. Absolutely.
And a common way of describing it to the legislature, to the, like I said, to the regulators, to the legislatures, and to the public, so they're getting a coherent message, particularly as we're going to shift language.
Right.
Yeah.
Yeah, the one comment I will make is there has been some discussion within the Committee on Adaptation to a Changing Climate to write a short paper that frames the problem, right, and why this language is confusing and why we need to explore changing it. Because, I mean, obviously it goes well beyond, engineering design and our communication with the legislature. I mean, the insurance and the risk and reinsurance industry, the commercial, the whole kind of real estate market, real estate industry, they're dealing with this. They just don't understand what they're dealing with. All they know is like, oh, well, it seems like every year we're having a 1 in 100-year flood. They don't really understand the fundamental problem. So I think we're going to need to communicate it fairly broadly to help, drive some momentum towards change. And so we can talk about that more.
Yeah, and then I'll add to that, because we're seeing that particularly around levees, and people finding out levees are overtopping, and that they're like, well, this was designed for the 500-year storm, or the 500-year event, and the levee overtopping and the changes with that, and all the things that go with it is really a challenge, because there's a town in Alabama that had a 100-year storm up the levee size, had a 500-year storm, and then flooded and basically got trapped in a bowl. And those are the challenges with the language we're going to have to deal with.